Welcome back. In the last module, we learned that system administrators have lots of responsibilities, like maintaining infrastructure services. IT infrastructure services are what allow an organization to function. These include connecting to the internet, managing networks by setting up the network hardware, connecting computers to an internal network, etc. In this lesson, we're going to learn about the common IT infrastructure services out there and what you need to know to start integrating them into an organization. We'll also dig deeper into each infrastructure service individually. We will focus more on the physical infrastructure services like servers, along with network infrastructure services that keep your company connected to the internet. In short, we'll be servicing all your infrastructure services needs. There are lots of IT infrastructure services that keep a company running. In a smaller company, a single person could be responsible for all these services. In larger companies, teams of sysadmins might manage just one service. In this course, we're going to discuss what you'll need to set up these services as the sole IT person in a company. We'll also give you an overview of some of the cloud services that you can utilize if you wanted another company to run your services. Reminder, as we mentioned before, cloud services are services that are accessed through the internet, like Gmail. We can access our Gmail accounts from any computing device as long as we're connected to the internet. By the end of this module, you should be well versed in what services you'll need to have a functioning IT infrastructure for your company. There are lots of types of IT infrastructure services out there. We'll start by giving you a high-level overview of them in this lesson. Then we'll dive into the nitty-gritty details on how you configure and maintain these services in later lessons. Sounds good? Let's get started. We talked about physical infrastructure components of an IT environment in an earlier lesson. Remember that you can set up different servers to run your services on, like a server to run your file storage service. You can buy or rent hardware for these servers and set up and store them either on-site or at another location. Essentially, you manage these servers end-to-end. There's another option. If you don't want to be responsible for managing the hardware tasks and updating your server operating systems with security patches and updates, you can use the cloud alternative to maintain your own infrastructure, which is called Infrastructure as a Service, or IaaS. IaaS providers give you pre-configured virtual machines that you can use just as if you had a physical server. Some popular IaaS providers are Amazon Web Services and their Elastic Compute Cloud, or EC2 instances, Linode, which rents out virtual servers, Windows Azure, and Google Compute Engine, which you've been using throughout this course. You can read more about the different IaaS providers in the supplemental reading right after this video. Your company's internal network isn't going to be like your network at home. You're going to have multiple computers that need to be on a certain subnet. You have to assign them IP addresses statically or using DHCP. The networking hardware has to be set up. Wireless internet will probably need to be available. DNS needs to be working, etc. If your company is large, networking is usually taken care of by a dedicated team. But in smaller companies, you'll probably be responsible for setting up the network. Network can be integrated in an IaaS provider, but in recent years, it's also been branched off into its own cloud service, Networking as a Service, or NaaS. NaaS allows companies to offshore their networking services so that they don't have to deal with the expensive networking hardware. Companies also won't have to set up their own network security, manage their own routing, set up a WAN, and private intranets, and so on. For more about NaaS providers, check out the supplemental reading. Let's talk about the software that your company might want to use. Do you need to type out Word documents, use an email client, communicate with other people, use operating systems, process spreadsheets, or have any other software needed to run a business? I bet yes. The right software has to be available to your company's users. We've already discussed how to install and maintain software and machines. You have to deal with things like licenses, security, updates, and maintenance for each machine. The cloud alternative to maintaining your own software is known as Software as a Service, or SaaS. Instead of installing a word processor on every machine, you can use Microsoft Office 365 or Google's G Suite. These are both services that you can purchase that allow you to edit Word documents, process spreadsheets, make presentations, and more, all from a web browser. You can check out the next supplemental reading for more about SaaS providers. Some companies have a product built around a software application. In this case, there are some things that software developers need to be able to code, build, and ship their software. First, specific applications have to be installed for their programming development environment. Then, depending on the product, they might need a database to store information. Finally, if they're serving web content like a website, they'll need to publish their product on the internet. If you're building this entire pipeline yourself, you may need to set up a database and a web server. The programming development environment will also have to be installed on every machine that needs it. If you want an all-in-one solution to building and deploying a web application, you can use something called Platform as a Service, or PaaS. This includes an entire platform that allows you to build code, store information in a database, and serve your application from a single platform. Popular options for PaaS are Heroku, Windows Azure, and Google App Engine. As you might have guessed, you can read more about PaaS providers in the supplemental reading. The last IT infrastructure service we'll discuss is the management of users, access, and authorization. A directory service centralizes your organization's users and computers in one location so that you can add, update, and remove users and computers. Some popular directory services that you can set up are Windows Active Directory, OpenLDAP, and we'll dive a little deeper into both of these later on in this course. Directory services can also be deployed in the cloud using Directory as a Service, or DaaS providers. Guess where you can read more about DaaS providers? That's right, in the supplemental reading. There you have it. There's a general overview of the most common IT infrastructure services you'll encounter when handling system administration tasks. While cloud services are a great option, it's super important that you understand how a service works and how to maintain before you employ the help of a cloud service. Even though cloud services are widely used in the industry and have a lot of pros, there are also some cons. These include recurring cost and the need to depend on the provider's service. We're going to teach you about the technical details and the implementation of these common IT infrastructure services. We'll cover everything from setting up your own server and figuring out which applications you need to be productive to how to set up multiple users and get your network services in order. By the end of this course, you have the foundational knowledge required to set up the IT infrastructure for a small organization. When we introduced Qwicklabs in the first course, we said that it uses Google Cloud Console. Now that we know more about the cloud and IT infrastructure services, let's dive deeper into what happens behind the scenes. When you press the Start Lab button, Qwicklab creates a new Google Cloud Console account for you with the same access to the console and services you would see as a paying customer. Each lab has a pre-configured list of actions that need to be performed during setup. This includes spinning up a virtual machine with a specific CPU and memory configuration and installing the VM with a specific operating system, Windows or Linux. It also configures any other cloud resources needed for the lab, like additional virtual disks for the virtual machine. During the lab, you can access the instances that Qwicklab created for you by using SSH or remote desktop. You can operate them in the same way you would use physical machines running that operating system. As you may have realized, a virtual machine behaves almost exactly like a physical machine. Once the lab is finished, Qwicklab destroys the virtual machine. This way, any CPU, memory, and storage used by the VM is returned to the provider's pool of available resources, so they can be used by other virtual machines doing other work. So there you have it. You've got a better idea of what's going on behind the scenes when you start Qwicklabs in our courses. When you want to set up a server, you essentially install a service or application on that server like a file storage service. Then that server will provide those services to the machines that request it. Maybe you thought you'd install services on a user operating system like Windows 10. While that's an option, typically in an organization, you'll want to install your services on a server operating system. Server operating systems are regular operating systems that are optimized for server functionality. This includes functions like allowing more network connections and more RAM capacity. Most operating systems have versions specifically made for servers. In Windows, you have Windows Server. In Linux, many distributions come with server counterparts like Ubuntu Server, which is optimized for server use. Mac OS is also available in Mac OS Server. Server operating systems are usually more secure and come with additional services already built in, so you don't have to set up these services separately. You can read more about the different server operating systems in the next supplemental reading. For now, just keep in mind that when you install services on a server, you should be sure to use a dedicated server operating system. We discussed virtual machines in the last course and covered how to set up a virtual machine on a personal computer. In this lesson, we're going to talk about why virtualization can be an important part of infrastructure services and systems administration. There are two ways you can run your services, either on dedicated hardware or on a virtualized instance on a server. When you virtualize a server, you're putting lots of virtual instances on one server. Each instance contains a service. There are a bunch of pros and cons to running your services on either of these platforms. Here's the rundown. Performance. A service running on a dedicated hardware will have better performance than service running in a virtualized environment. This is because you only have one service using one machine, as opposed to many services using one machine. Cost. Server hardware can be pretty expensive. If you put a service on one piece of dedicated hardware and have to do that for 9 other services, it starts to add up. One of the huge benefits to virtualizing your servers is that you can have 10 services running on 10 different virtual instances, all on one physical server. Here's another way to think about this. In a typical server, if you only have one service running, it's probably only taking up 10 to 20% of your CPU utilization. The rest of the hardware isn't being utilized. You could add plenty more services to the physical server and still have a good threshold for resource utilization. It's cheaper to run several services on one machine than it is to run many services on multiple machines. Maintenance. Servers require hardware maintenance and routine operating system updates. Sometimes you need to take the service offline to do that maintenance. With virtualized servers, you can quickly stop your service or migrate them to another physical server, then take as much time as you need for maintenance. Virtualized servers make server maintenance much easier to do. Points of failure. When you put a service on one physical machine and that machine has issues, you're entering a world of trouble. With virtualized servers, you can easily move services off a physical machine and spin up the same service on a different machine as a backup. You could also do this with a physical server, but that could become costly if you account for multiple servers. Pro tip, you can prevent a single point of failure on a physical machine if you have a redundant servers set up, meaning you have duplicate servers as a backup. You'll learn about backups in an upcoming module. As you can see, there are lots of benefits to using virtualized servers. Just make sure to weigh the pros and cons of virtualizing your servers and using dedicated server hardware. That way, you can make the right choice for your company. Another important part of physical infrastructure services is the ability to connect to your infrastructure from anywhere in the world. We talked about remote access in an earlier course, and we've been using it all throughout this program to connect to our lab machines. In this lesson, we're going to discuss what's needed to set up for remote access for a small organization. As a systems administrator or as anyone in IT support, you'll want to be able to remotely access another server or user's machine so that you can troubleshoot an issue or do maintenance from wherever you may be. In Linux, the most popular remote access tool is OpenSSH. We've already learned how to SSH into a remote computer in the last course, and we talked a bit about what's needed to set up SSH, but we'll quickly show you how to do this. To SSH into another machine, you need to install an SSH client on the machine you're connecting from. Then install an SSH server on the machine you're connecting to. To learn more about OpenSSH, you can check out the next supplementary reading. But let's keep rocking and rolling with how to install the OpenSSH client on a machine. It's super easy. What you're going to do is I'm going to go to my client machine and simply run this command, sudo apt-get install OpenSSH client. And it's downloading the package. Perfect. So it looks like my client has been installed. Next, you need to install the OpenSSH server on the machine you want to access. Remember, the SSH server is just a process that listens for incoming SSH connections. So let's go to the server and install the OpenSSH server. So I'm going to do sudo apt-get install OpenSSH server. Perfect. So it looks like my server is up and running. So let's go back to the client and do a test. I do SSH, enter my server IP address with my username. So ask for my password, which is a good thing. Perfect. So as you can see, I'm connected to my server, and one true way to test this is if I go into my desktop of my server, and let me create a folder. Now if I go back to my server, which is on this window, I list the files, you can see the folder test, and that's it. Now you're able to SSH into a machine from another machine. Not too complicated, right? Windows has similar tools that you can use. A popular tool to access the CLI remotely is WinRM or PuTTY. RDP is also popular if you want to access the GUI remotely. We've already discussed how to connect to a machine using PuTTY in the last course. Just remember to install an SSH server on the machine you want to connect to. We also already discussed how to set up RDP in the last course. Feel free to review those lessons as a refresher. You can read more about the Windows remote access tools in the next reading. The takeaway here is that when you manage IT infrastructure, you can utilize tools like remote access to work on your physical infrastructure. You'll need to do a little bit of setup beforehand, like installing the SSH client, SSH servers, and allowing remote desktop connections, etc. But it'll be worth it in the long run. Now that we're a little more familiar with some of the common aspects of physical infrastructure, let's move on to network services. A network service that's commonly used in an organization is a file transfer service. So, why would you want to have a service dedicated to file transfer? Well, sure, you could probably carry around a flash drive and copy files to each machine you work on, or even use the remote copy tools we learned in the last course. Or you could centrally store your files and transfer files from one computer to another using the internet. There are a few different file transfer protocol services that are used today. Let's take a quick rundown of what's out there and what they do. FTP. In the second course of this program, the bits and bytes of computer networking, we mentioned FTP, aka the file transfer protocol. It's a legacy way to transfer files from one computer to another over the internet, and it's still in use today. It's not a super secure way to transfer data because it doesn't handle data encryption. The FTP service works much like our SSH service. Clients that want to access an FTP server have to install an FTP client. On the FTP server, we install the software that allows us to share information located in a directory on that server. FTP is primarily used today to share web content. If you use a website host provider, you might see that they have an FTP connection already available for use, so they can easily copy files to and from your website. SFTP is a secure version of FTP, so it makes sense to choose this option over FTP. During this SFTP process, data is sent through SSH and is encrypted. TFTP stands for Trivial FTP. It's a simpler way to transfer files than using FTP. TFTP doesn't require user authentication like FTP, so any files that you store here should be generic and not need to be secure. A popular use of TFTP is to host installation files. One method of booting a computer that we haven't discussed yet is PXE or PXE boot, which stands for pre-boot execution. This allows you to boot into a software that's available over the network. A common use case for organizations that want to install software over a network is to keep operating system installation files on a TFTP server. That way, when you perform a network boot, you can be automatically launched into the installer. This is a lot more efficient than having to carry around a USB with an operating system image. You can learn more about PXE boot in the next reading. Depending on your usage of file transferring services, you might want to weigh the option we mentioned. We encourage you to read about popular FTP clients used in the supplemental reading. If you just want to share files between your computers in a secure way and have a nice directory where you can access all the shared files instead of transferring them to your machine, you'll want to look at network file storage services instead. We'll discuss those in an upcoming module. One of the oldest internet protocols in use today is the Network Time Protocol, or NTP. It's used to keep the clock synchronized on machines connected to a network. You've probably seen NTP implemented in your personal life if you've ever been in an airport. Airports utilize synchronized clock systems, and many of their systems use NTP. This is because the information that you see on your departure and arrival screen has to match the time that the air traffic controller team sees for their airplanes. If only NTP could solve for airport delays. In the IT world, machines need to have accurate time across the network for a lot of reasons. There are some security services like Kerberos, a network authentication protocol, that depend on the time being consistent across the network to work. You'll learn more about that in the IT security course coming up. It is important to keep the time consistent and accurate across your company's fleet. You can't depend on the hardware itself to keep consistent time, so you might want to set up an NTP server. There are different ways that an IT support specialist or SysAdmin can do this for an organization. You can use a local NTP server or a public NTP server. To set up a local NTP server, you can install NTP server software on your managed server. Then you install NTP clients on your machines and tell those computers which NTP servers to sync their time to. This is a great option because you can then manage the entire process from end to end. The other way to set up NTP is to use a public NTP server. Public NTP servers are managed by other organizations that your client machines connect to in order to get synchronized time. This is an awesome way to utilize NTP without having to run a dedicated NTP server. But if you have a large fleet of thousands of machines, it's better etiquette to be running your own NTP servers. Another good practice is to run your own NTP server, then have that point to a public NTP server. This makes it so that you don't connect all your clients to a public NTP server and you don't have to measure time synchronization. Whether you run your own NTP server or use a public one, NTP is an important network service that you should definitely integrate into your own fleet. There are a few network services that are used internally in an IT enterprise environment to improve employee productivity, privacy, and security. While they're pretty common, you might not encounter them in small organizations. We discussed these services in Course 2 on networking, but let's do a refresher. We're sure that you'll encounter them at some point in your IT career. There are intranets and proxy servers. An intranet is an internal network inside a company. It's accessible if you're on a company's network. Intranets can provide a wide range of information and are meant to improve productivity by giving employees a greater medium to share information. Think of it like a company's website that's only accessible to people on the company network. On this site, documentation can be centrally located, teams can post news updates, employees can write to forums and start discussions, and more. Intranets are most commonly seen in large enterprises and can be an incredibly valuable tool for employee productivity. Another internal support service that's widely used is a proxy server. Proxy servers act as an intermediary between a company's network and the internet. They receive network traffic and relay that information to the company network. This way, company network traffic is kept private from the internet. The internet gets traffic through a proxy server, but it doesn't know where it originally came from. It only knows the proxy. Proxy servers can also be used to monitor and log internal company network activity. They can be configured so certain websites are filtered from being accessed. Proxy servers are useful for providing privacy and security on the internet and regulating access inside a company. In the next few lessons, we'll talk about what are probably the most essential network services, DNS and DHCP. We did a deep dive on DNS, or Domain Name System, in the networking course. If you need a refresher on it, make sure to review the material there. As a super quick recap, DNS is what maps human understandable names to IP addresses. It's an important network service to set up and maintain when managing a company's IT infrastructure. If you don't set it up correctly, no one will be able to access websites by their names. We don't really have to think about DNS on our personal computers. When you connect a brand new machine to the internet and start typing in a web address, it just works automatically. You don't have to type in IP address or anything, but something is happening in the background. When you connect to a network, you're using the DNS server address that was provided by the router you connected to. It updates your network setting to use that DNS server address, which is usually your ISP's DNS server. From there, you're able to access pretty much any website. So why do you need to set up your own DNS servers if DNS just works out of the box? Well, there's two reasons. First, if you're running a web service like a website, you want to be able to tell the internet what IP address to reach your website at. To do that, you need to set up DNS. The second reason is that you probably want to work on your server or user machines remotely. In theory, you could remote access into them through an IP address, but you could also just use an easy-to-remember hostname. To do that, you need DNS to map the IP address to the hostname. In the next couple of lessons, we'll discuss what's needed for DNS setup for websites and internal networks. You might remember that we can use a web server to store and serve content to clients that request our services. We'll probably want to store website content on our web server. If clients want to reach our website, we need to set up DNS so that they can just type a URL to find us. So let's talk about how DNS gets set up for a website. First, we need a domain name. We can buy a domain name like settingupdnsisfun.example.com. We can purchase domain names like this from companies called domain registrars, like GoDaddy.com or Bluehost.com. Once we have our domain name, we want to point our website files to this domain name. Our website files can be stored on a cloud hosting provider, or we can decide to control this ourselves and store it on our own servers. Typically, domain registrars also provide cloud hosting services, but they can charge you a monthly fee to host your web files for you. Pro tip: if you don't want to utilize cloud hosting services, you can just run your own web server. Don't forget, there are always pros and cons to hosting a service yourself or offshoring it somewhere else. So if you're the sole IT support specialist for an organization, make sure to weigh all your options before committing to an infrastructure service. Let's assume that we do want to host our website files ourselves. From here, we still need to point our new domain name to where our web content is located. We can do this in two ways. Most domain registrars can provide you with DNS settings, and you can give the IP address of where your content is stored. If you decide not to use your domain registrar to host DNS for you, then you have to set up an authoritative DNS server for your website. Remember from our discussion in Course 2 that authoritative DNS servers are the DNS servers that know exactly what the IP address is for the domain name? Since we own the domain name and host our web content ourselves, it makes sense for us to have the DNS servers that know that information. The other reason we might want our own DNS servers is so we can map our internal computers to IP addresses. That way, we can reference a computer by name instead of IP address. There are a few ways we can do this. One is using a local host file which contains static IP addresses to hostname mappings. Let's take a look at an example of this. Remember that we learned that host files in networking allows us to map IP addresses to host names manually. In Linux, our host file is called etc/hosts. It has an IP address that points to 127.0.0.1, which points to a name called localhost. This just references back to the computer. Localhost is commonly used as a way to access a local web server. We'll talk about web servers in an upcoming module. So for now, let's not worry too much about localhost. Instead, if I change this IP address mapping to www.google.com, then save and open a web browser and type www.google.com, it won't take me there. Let me show you that. So I'm going to go ahead and change my localhost to www.google.com. I'm going to save this, open my web browser to www.google.com. And as you can see, it didn't take me anywhere. It just takes me back to my local computer. This is because a DNS query first checks our local host file, then our local DNS servers. So if there's an entry for google.com in my host file, it will go to that IP address instead. Let's say I wanted to access Natalie's computer at 192.168.1.5 and her host name is catlady.examplecompany.com. I would have to enter this in my host file for every single computer in my fleet. That's definitely not a scalable option. Okay, so what's our next choice? We can set up a local DNS server that contains all the organization's computer names mapped to their IP addresses. This is a more central storage location for this information. Then, we change our network settings for all our computers to use this DNS server instead of the one given to us by our ISP. Finally, let's look at one of the last DNS options we can use for an internal network. It can be integrated with a directory service which handles user and machine information in a central location like Active Directory and LDAP. Once we set up DNS and our directory service, it will automatically populate with machine to IP address mappings. So there's no need to enter this information in manually. We'll talk more about these directory services in a later module. And voila! That's an overview of why you need a DNS, along with your options for configuring them. We won't dive too deeply into the technical details of setting up a DNS server, but if you are interested in learning about which DNS software to use, there are a few popular options like Bind or Power DNS. I bet you can guess where you can read more about them in the supplemental reading. One thing about DNS that we haven't discussed is what to do if we use something like DHCP, which doesn't use static IP addresses. Don't worry, we'll cover this in the next lesson. Another network service that will make your job in IT support easier is DHCP, or Dynamic Host Configuration Protocol. Need a refresher on DHCP? Just check out the DHCP lessons in the networking course. When managing IT infrastructure and you want to connect a computer on a network, you have two options. You can grant it a static IP address or give it a DHCP assigned IP address. When you use a static IP address, you have to keep track of every IP address you assign a computer and manually enter it in the network settings. If you enable DHCP, your computers will be leased an IP address from a DHCP server. They'll automatically get IP addresses and you don't have to worry about manually setting addresses. If you ever decide you need to expand your IP address range, you don't have to change anything on the client machines either. It just happens automatically. To configure a DHCP server, you'll need to figure out which IP range you can use to assign IP addresses. If you want to integrate with DNS, you'll need the address of your local DNS servers, what gateway you should assign, and the subnet mask that gets used. Once you install the DHCP server software, you have to configure the settings with this information. Different DHCP server software manufacturers have different configuration setting layouts. So you'll have to investigate the specific one you want to use. There are a lot of popular DHCP server software you can use for this. Windows Server versions come with DHCP service built in, but you can read more about the options in the next reading. Once you turn on your DHCP server and your clients are set to receive DHCP addresses instead of static IP addresses, you should have working DHCP settings. In the last lesson, we talked about how DNS ties in with DHCP. Well, in our DHCP configuration settings, we can specify DNS server locations. The two servers then sync up, and when DHCP leases out new addresses, DNS updates its IP address mappings automatically. That's a super quick overview how DHCP servers are configured. Hopefully, you can now see why DHCP and DNS are critical network services for your organization. There will be times when you're working in an IT support role and you won't be able to resolve or get the IP address of a website name. This particular problem could be tricky to identify when you see it. You might just think that your network connection isn't working. Let's go ahead and try to navigate to google.com from my web browser. So let me get to my web browser and navigate to google.com. Oh, it doesn't look like we can get to google.com. Let's go over some of the tools that we learned in our networking class that can help. First up, if you're unable to resolve a domain name, check that your network connection is actually working. You can do a quick check and ping a website that you know is available. An oldie but goodie is to ping www.google.com. It's pretty rare that Google will be down, although it can happen. So let me go into my terminal and type in ping www.google.com. Looks like we're getting responses. Let's move on to isolating another problem, DNS. To verify that your DNS server is giving you a correct address for google.com, you can use NSLookup. Remember that NSLookup gives us the name server of a host or domain name. So let me go ahead and do that on my terminal. From here, we can rule out if DNS is an issue by verifying that the host name points to a named server. If we copy the IP address of the result and paste it into the web browser, it should resolve the website name if DNS is working. Let's go ahead and do that. So I'm going to go ahead and copy the non-authoritative IP address. Open my web browser. Oh, so I see that's working. What's going on? Looks like my DNS settings aren't working correctly. Let's look at my ping results again. So I'm going to go ahead to my terminal and ping www.google.com. I see that it checks an IP address different from what I have here. If I go to this IP address, it doesn't take me anywhere. So I'm going to take this IP address, copy this. Remember that when a DNS query is performed, your computer first checks host file. Now, if I access my host file here, I can see that I have an entry for www.google.com, and it points to a fake IP address. If I remove this line right here where it says 127.1.1.3 and save that configuration file, and then restart my browser, if I type in www.google.com, there we go, we're there. And the correct DNS setting should be applied to www.google.com. There are some situations where DNS can be tricky to navigate since there can be many contributing factors. But as with any troubleshooting scenario, remember to keep isolating the problem down until you can get to a root cause. With time and experience, you'll learn a lot more about DNS and how to troubleshoot it in the real world.
Congratulations on finishing this lesson from the Google IT Support Certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career Certificates.